let's talk about rectangles. You first learned about rectangles when you were a little kid, maybe in pre-kindergarten or whatever preschooling you had. But now that you're in, likely if you're listening to this, in a high school geometry class or preparing for a high school level standardized test, you're going to come to know rectangles as something a little bit more in depth, a little bit more complex than you did when you were a little kid. First off, rectangles are a specific type of parallelogram, and what that means is that all of the characteristics that you learned about parallelograms also apply to rectangles. But because rectangles are a special kind of parallelogram, we're going to add a few special traits that you're going to need to know. So, one thing, the most famous, I guess, trait of a rectangle is that it contains a right angle in one of the corners. But it doesn't just contain one right angle, because a rectangle is a parallelogram. That means that consecutive angles are supplementary. That means that its next door neighbor angle has to add up with it to 180 degrees, which means 90 plus 90. So both of those angles have to be right angles. It also means that opposite angles are congruent, because that is a trait of a parallelogram. So if that bottom left corner is a right angle, that means this top right one has to be. And since the top left is, that means the bottom right has to be. So in reality, a rectangle has to have 4 right angles. The other fact about rectangles is that like all parallelograms, the diagonals bisect each other, meaning they are cut into equal parts or halves. But since a rectangle is an upright shape as opposed to a leaning shape that we think of with a regular old parallelogram, the diagonals are also the same length. They are congruent to each other, which means that their halves, all 4 halves, are the same length as well. So those are really the newest things that come with studying rectangles. Now, I've referenced parallelograms a lot so far. I would encourage you, if you need a refresher, to watch my parallelogram video. I will put that link in the comments for you to click on and refresh your memory and enjoy. So, now that we know the unique characteristics of rectangles, in addition to all the ones that go with parallelograms, let's see how those could be represented in different math problems in your geometry course or your standardized test. So first, we're going to take a look at this problem here, where we've got those 2 little angles up there in the top left. So that's angle DAE and angle BAE. And they are each represented with an algebraic expression. Now, the key is we have to bring in our knowledge of rectangles to make an equation that's going to help us solve for x. So we have to know that angle DAB, the big angle up there, is going to be a 90-degree angle. That means that 3x plus 23 and 6x minus 5 represent 2 complementary angles that add up to 90 degrees. So let's set that up as an equation. We'll do 3x plus 23 plus 6x minus 5 equals 90. There's our base equation. Now, we have some solving that we can do, some simplifying. That's going to give us 9x, and 23 minus 5 is plus 18. We'll still add up to 90. Let's move up just a little bit here temporarily. That's going to give us 9x equals 72, and x equals 8. And from here on, it kind of depends on what the question is that you are asked for. If you're asked just to solve for x, you're finished. If you need to plug in x into these expressions to get specific angle values, angle measures, you can. So let's go ahead and do that. Let's do 3 times 8 plus 23 will be 24 plus 23. So this angle here is 47 degrees. And we can just use subtraction. 90 minus 47 would give us 43 for this top angle, although if you plugged in 8 into 6x minus 5, you would get 43. So that is a type of problem that uses the unique traits of rectangles to solve for angle measurements. Let's now go in and look at some diagonal traits here. So AC in this problem, AC is a full-length diagonal, and it is 10x minus 8. DB is the other diagonal, 8x plus 2. Now we know that in rectangles, diagonals are congruent. So congruent means they have equal measures. So let's write that up. 10x minus 8 equals, because we said those parts were equal, 8x plus 2. That's going to give us 2x equals 10, or x equals 5. And we were just asked to solve for x. And so we've done that. We could, if we were asked, plug that 5 into the x's in our original problem, and we'd get that each diagonal is 42 units long. But we weren't asked that, so we won't write it out. But it's not any surprise to us that we would get the same thing for AC that we did for DB, because that was our whole premise for the problem. Let's look at a different diagonals problem here. Here we're looking at parts of diagonals. Here AE, which is right there, is 3x plus 5, and DE, which is right there, is 5x minus 3. So we know that in a rectangle, the diagonals are not only equal in length, they are also bisected, because they are a rectangle is a type of parallelogram where diagonals are bisected. So we know that all of these parts, all 4 of these lines that meet up here in the middle at E, are going to be congruent. So let's set up 3x plus 5 equals 5x minus 3. That's going to give us 2x equals 8, or x equals 4. Well, we weren't just asked for x here, we were asked for EB. And we know that it's going to have the same length, just like these other ones do, of these. So we can take this x value and plug it into either of those and get the value of EB, which will be shared by AE and DE and CE. So I'm just going to choose kind of arbitrarily to plug it into the top one, 3 times x plus 5, and that's going to give us 17. All right. Now, a little bit of a more advanced task that you might have with rectangles is the fact that because these 4 parts, these 4 parts, let's try this again. Because these 4 parts, there we go, are all congruent, it sets us up to have some problems where we have isosceles triangles. We can use the different facts surrounding isosceles triangles to solve problems. So for example, here we might be asked to find the measure of this angle here, EAD, which is right here. Now, we don't have any of the angles in there right now, but we do have this 126 degree angle here. And we remember that these angles here are what we called a linear pair, and they have to be supplementary. So supplementary means they add up to 180. So I'm going to do 180 minus that 126, and I'm going to get 54. 54. 4 for this angle right here. And furthermore, I know a little thing or two about isosceles triangles in that the base angles, the angles at the ends of these legs, are going to have the same measure. Angles opposite congruent sides are themselves congruent. So if I know, let's see, I'll call it x, which means I can also call this one x. So I can set up an equation like x plus 54 equals 180. And I can do that because the three angles in any triangle add up to 180. And it just so happens that the base angles in this isosceles triangle, as with all isosceles triangles, are equal. So x plus x is 2x plus 54 equals 180. So 2x is equal to 126, which means x is equal to 63. So this angle up here is 63 degrees, and this angle here is 63 degrees. And a quick check, yes, 63 plus 63 will be 126 plus 54 up here gives us 180. So don't lose sight of the fact that you can have all kinds of triangle tricks embedded in your parallelograms, depending on, or in your quadrilaterals, depending on what kind of quadrilateral you have. In this rectangle, we actually have 4 isosceles triangles. And that could be used to find lengths or missing angle measures or what have you. So I hope you found this video helpful. If you have other ideas for topics we could explore in a future video, please leave it in the comments. If you have any further questions, feel free to throw those in the comments as well. I appreciate you watching. Tell all your friends, and good luck with your math. Take care.